Hey y'all, in this video, we're going to be learning about applying trig functions to angles of rotation. And essentially this is leading to the unit circle. So you're going to get your introduction to the unit circle with this lesson. These concepts that we're going to be learning today are leading to the unit circle, which is something that you're going to be using all throughout trigonometry. So this is something you really want to grasp and fully understand or have handy with you as you navigate trigonometry throughout the course. Okay, so we can define trig functions in terms of angles of rotation like we did for angles in right triangles. So I have a circle here. We're going to call this, we'll just call it the circle for now. And I've got a triangle measured out in this circle, and I've labeled the triangle as X, Y, and R. And for the sake of this example, we're going to let the radius equal 1. And when the radius equals 1, I have it down here further, but when the radius equals 1, we refer to this as the unit circle. And we're going to be using this all the time. Cannot stress that enough. So we want to find X and Y using SOHCAHTOA so that we can formulate some important things we need. All right, so if we're considering angle theta, sorry, and 1 is the hypotenuse, then we can say the sine of theta is opposite, which is Y, over hypotenuse, which is 1 in this case. And then Y over 1 is just Y. So I can say that Y equals sine theta. And then if I wanted to find X, I'm going to use cosine theta because X is adjacent. So we do adjacent over hypotenuse, simplify, and cosine theta equals X. So if X equals cosine and Y equals sine, then I can substitute, if I have the point X comma Y, I can change that now to cosine theta comma sine theta. I switched to cursive there, old habit. That's how I used to do it when I was going to school. So if you don't like cursive, sorry about that. There you go. Sometimes when you write in print, it looks like numbers, like the I looks like a 1. So I used to just write in cursive. If you like that, you can do it, but old habits. All right. So in summary, X is always associated with cosine and Y is always associated with sine. And that's going to be key later in the course. Now we're going to define the 6 trig functions using this information above where R equals 1. We know that sine equals Y over 1 or just Y. And we know that cosine equals X over 1 or just X. Mess that up. Tangent is TOA. So TOA, if I were to go up here, is opposite over adjacent. So that's going to be Y over X. Which later you'll find, I mean, if Y is sine, I'm spoiling this for you later on, sorry, and X is cosine, but this is what we're looking for. I just get excited because that's neat to me. Anyway, okay, cosecant is the reciprocal of sine. So we're just flipping sine, 1 over Y. Secant is the reciprocal of cosine, so we're flipping cosine. And cotangent is the reciprocal of tangent, so we're flipping tangent. So these ratios here are going to help us solve problems later on. So like this example down here, the point -3, 4 is a point on the terminal side of an angle in standard position. So they did initial side, terminal side, 3, 4. And we're going to determine the values of the 6 trig functions of the angle. So we're going to be, we've got this angle triangle formed, sorry. And we're going to be looking at this angle here. And we're going to do sine, cosine, tangent. I should switch that. I'm going to make this more organized. The dog is scratching my arm. Okay, and then the right side of this table will be cosecant, secant, and cotangent. I wanted to clarify something before we get started that I didn't mention. I did say theta was here. So you're probably wondering, why did we draw this triangle here? Well, this angle, the new theta that we're considering, is called a reference angle. So this looks like maybe it's 135. It's past 90 degrees, maybe 45 degrees. I don't know. I'm just estimating here. And then also with this axis, that would be a 45 degrees. So they're called reference angles. And that's why we can use this triangle instead to find that measure. So sine theta is going to be opposite over hypotenuse. Cosine theta is going to be adjacent over hypotenuse. Now, why is that negative? If you think about it, this is 3 units, but it's in the negative quadrant. So it's actually -3. And if you look at the x value, the x value is -3, so that does make sense for it to be negative. And then tangent is opposite over adjacent. That will be a -3. I don't really like to put the negative in the bottom, so I'm just going to put it outside in the front. You can use it in the numerator with the 4, or you can just put it out front completely. Either way is okay. So now I want you to find the remaining 3. Pause it, try it, come back. These are all reciprocal functions, so basically you just have to flip the fractions, go ahead and keep the sign of the original. So cosecant is 5/4, secant is -5/3, and cotangent is -3/4, and that's all you have to do. So we're just essentially using SOHCAHTOA, reference angles, and reciprocal functions. Very, very straightforward. So let's use this concept to go more into the unit circle. And this is what I was talking about earlier in the video, that is something that you're going to use over and over and over again. So my goal here is to use basically not the reference angles, but the original angles that you're going to see all the time. And then if you can formulate what those angles equal, then you can figure out their reference angles or coterminal angles. All right, remember in the unit circle, the sine and cosine of an angle are the x and y coordinates of the point on the terminal side. So let's use the unit circle to find each. Now, I'm saying that x is cosine and y is sine. That's a true statement throughout. So if I look at cosine of 90 degrees, then I'm focusing on this here. And we've got cosine is x over 1, or adjacent over hypotenuse. So if I take x over 1 and simplify, I get 0. So cosine of 90 is 0. So for cotangent, if we look up previously at the table we did earlier, the ratio for cotangent is x over y. So I'm going to take the x coordinate of the 180 degrees, that's -1, over the y coordinate is 0. I got that from right here. And then I simplify. Anything over 0 is considered undefined, so the cotangent of 180 degrees is undefined. And then secant is 1 over x from our table above. the reciprocal of cosine, and I'm focusing on the angle 0. So I'm doing secant of 0 is 1 over the x coordinate, which is 1, and 1 over 1 is 1. So if you are finding the trig value of, or the angle value of trig functions by hand, you're going to be using those ratios from this table here. So we have the x and y coordinates, and we're using the x and y coordinates to figure out specific angles. So this example was just a generic angle theta, but they did give us the x and y coordinates. And so with the x and y coordinates, we could figure out what that was. And then here we have specific angles, and we're using specific angles to find those values. So cosine of 90 degrees is 0. Cotangent of 180 degrees is undefined. Secant of 0 degrees is 1. And you can do that for all the trig functions for any angle, but we're just focusing on these quadrantal angles for now. And then we're going to be focusing on some other key angles. These angles that we're going to be looking at are 30, 45, and 60. We've already looked at 90. 90's in there is one of the important ones, but basically these angles in this region, we're going to figure out what the trig functions are of those angles, because if we can figure out those angles, not if, when we figure out these angles, all the ones on that quadrant, then if we just change the signs, we can use their reference angles to figure out all the others. So 45, if I can figure out 45, then I can figure out 135 and 225 and so on. And then if I, 30 and all the reference angles, then we have them all. So the key here is that you want to be able to generate these. And once you have those, you have all the others. Let's start with 30 degrees. 30 degrees, I have my initial side, and then 30 is about here, we'll call it, just estimating. 30 degrees. And I know that the radius, this is the unit circle, so I know that the radius is 1. What I also know about this angle is that if I drop a segment here, I now have a 30, 60, 90 triangle. And I have the ratio for a 30, 60, 90 triangle because we've already found it from a previous video, and that is here. So all I have is the radius, and I know that it's a 30, 60, 90 triangle, which means that I can find x and find the missing sides. And remember, what we're doing here, basically the key is we're trying to find where this hits on the unit circle. I don't think I said that earlier, so don't remember. That's what we're doing. We're trying to figure out this point here, which basically we're going to have to find x and y to figure out that point right there. So with the 30, 60, 90 triangle, I am given the side across from the 90 degrees. That is 1. So if I take 2x and I set it equal to 1, divide both sides by 2, then x is a half. So that means I now have the side across from the 30 degrees and the side across from the 60 degrees. I am going to simplify this a little bit. 1/2 times root 3. If you put root 3 over 1 and multiplied the fractions, you would get root 3 over 2. So that's kind of how we write it there. So the side across from the 30-degree angle is 1/2, and the side, I'm sorry, I said across, opposite, opposite of the 30-degree angle. And then the side adjacent to the 30-degree angle or opposite of the 60-degree angle, however you want to look at that, is root 3 over 2. So I have found x and y. The x coordinate, it goes over root 3 over 2, and it goes up a half for a 30-degree angle. And with that, I can find all of the trig. I'm going to change that to 30. Sorry. Sine 30, cosine 30, tangent 30, and then cosecant 30, secant 30, cotangent 30. Okay, now knowing x and y and knowing your trig ratios, I want you to pause it, try these, and come back. On 3 of these, you're going to have to do a little bit of algebra to simplify. Basically, you have to rationalize the denominator. Sine of 30 was very simple. It was the y value. Cosine of 30 was very simple, was the x value. Tangent 30 got a little messy. You do y over x. And when you divide those fractions, you flip the second and multiply, you get 1 over square root 3. So that square root 3 in the denominator is a bit of an issue. So what we do is we rationalize it. And to do that, I'll go ahead and show you 1 over square root 3, multiply top and bottom by square root 3. We get square root 3 over square root 9, which is square root 3 over 3. So that's where I got that solution. Square root 3 over 3. And then cosecant 30, very simple. Flip that 1 over 2 to get 2 over 1. Secant 30, a little more work. You got to flip that root 3 over 2, and you end up with 2 over root 3. You have to rationalize the denominator, multiplying by root 3 on top and bottom. Simplify, you get 2 root 3 over 3. Sorry, it's a mouthful. And then the last one, cotangent 30, flip that thing that you got for tangent, rationalize the denominator, reduce, and you get root 3. So all that to say, we now have the 6 trig functions for 30 degrees. And these are important. You're going to want to keep these in mind throughout trigonometry. It doesn't go away. Once you use it a lot, you'll probably just start to kind of memorize these. I never want to promote just rote memorization. I'd rather you know where they come from, which is why we're going through this exercise. All right, let's do the same thing for 45 degrees. So I've got my terminal side at 45 degrees. I'm going to drop a segment there, and that gives me this triangle here, a right triangle. I know that the radius is 1. And I'm trying to find the x and y coordinate for 45 degrees so that I can use that to find all the trig functions. So I want you to use your knowledge of a 45, 45, 90 triangle and recall the ratios for that, and then solve this. Try to do it and find each trig function. I'm going to do some simplifying here. Just make this smaller. Pause it, try it, come back. So to get started on this, you're going to want to write out the ratio for 45, 45, 90. That's x root 2. We were given the hypotenuse, which was 1, since it's a unit circle. If you solve for x and simplify, you should end up with square root 2 over 2. Now, that gives us x, which gives us the 2 missing sides, since those 2 sides are equal. So I put those here, root 2 over 2, root 2 over 2. And now I can go about my trig functions. Sine of 45 is the y coordinate for the opposite side. Same thing. Root 2 over 2. Cosine 45 is the x coordinate for the adjacent. And tangent 45 is y over x. So if I were to flip that and multiply, I would end up with 1. I'll write that down here. Tangent 45 is 1. Then for the reciprocal functions, we're just going to flip those and simplify. when you do cosecant, the twos divide and you end up with just root 2. Secant is going to be the same thing, root 2, and then cotangent, if you flip 1, you just get 1. So those are the trig functions for a 45-degree angle. And again, these are important. You're going to see them again. So keep these handy or in mind as you continue. And then the last one we're going to do is 60 degrees. Yay! And after we do 60 degrees, we'll build out our circle. So 60 degrees is going to be more up here. I'm going to drop that segment to form the right angle. And my radius is 1. That's across from the right angle. Again, this is going to be a 30, 60, 90 triangle. So we've kind of done the work for this already in the previous example with 30. That was x root 3, 2x. Across from the 90 was 1. So that gave us a half here and root 3 over 2 here. So I'm just pulling up the previous information to kind of fast forward this a little bit. Across from the 60-degree angle is root 3 over 2. Across from the 30-degree angle is a half. So my x is a half, my y is root 3 over 2. So if you can kind of visualize what's happening here is if we were to plot this point, that point would be over a half up root 3 over 2, x comma y. So that's what we're finding. Now do the trig functions, pause it, do the trig functions, come back and check your work. As you work, you might recognize some of these values, or you should recognize these values from the 30-degree angle. Basically, we just kind of switch some stuff around because of where the sides are, or the x and y coordinate. If you remember with the 30-degree angle, the x coordinate was root 3 over 2. And now with the 60-degree angle, it's the y coordinate that's root 3 over 2. And so that's why your trig functions are going to be switched a little bit. For sine, you should get root 3 over 2. Cosine, you get a half. Tangent, you're going to do y over x. Divide that, simplify, you get root 3. Cosecant, when you flip 2 over root 3 and simplify, you get 2 root 3 over 3. Secant, you get 2, and cotangent, you get root 3 over 3. So those are your trig functions for 60 degrees. All right, I'm going to go down here. And we're just going to write the x and y values, which is sine and cosine, flip those x and y, cosine and sine, for each angle. I've already found 0, 30, 60, sorry, 30, 45, 60, and 90. So I'm going to fill those out, and then I'm going to use them to fill out the rest of the circle. So what I've done here is if you kind of remember what I was talking about earlier with, we're basically plotting points just on the unit circle. So if you're not wanting to like go back up or scroll back up or turn the pages to figure out, oh, what did we get for cosine of 0? What was that? If you just think about logically, if this is a point, if this is x and y axis, and this is a point on that coordinate plane, we're going over 1 up 0. So the point is 1, 0, x comma y. Now 30 degrees, I'm going to go over square root 3 over 2, up a half. And so that's x, y. 45 degrees, I'm going to go over root 2 over 2, up root 2 over 2. And then 60 degrees, I'm going to go over a half, up root 3 over 2. 90 degrees, I go over 0, up 1. And so that's what those points are. And we found the values of those points using the triangles in the previous examples. Okay, so now in this quadrant, these are reference angles, but the signs are going to change. So 180 is going to be the same as 360 or 0, but now it's going to be -1, 0, because we go left 1, up 0. Now try the other ones. Basically on these, only the X value changes because we're now on the negative side of the X axis. The Y value is still positive because we're on the positive side of the Y axis. So 150 is a reference angle for 30. Change the X value. 135 is a reference angle for 45, and 120 is a reference angle for 60. And now you will use that to complete the other two quadrants. So pause it, finish it, and come back. So for quadrants 3 and 4, for 3, sorry, let me back up. For 3, both are negative because X is negative and Y is negative. And then for quadrant 4, X is positive, but Y is negative. Same values. 30 and 330 are reference angles, 45 and 315 are reference angles, and 60 and 300 are reference angles. If you're not sure, if you just think about logically the X and Y coordinate, for 330, we're going over root 3 over 2, down a half, and so on. So that is the unit circle. You just created the unit circle. Again, this is something you're going to be using over and over and over. So I recommend that you keep this handy or at least be able to generate it yourself. And that's all I have for this lesson. So I hope you enjoyed it. If you have any questions, let me know. I'd be happy to help, and I'll see you in the next one.